Welcome to today's live demo, Tired of Repairing the Repairs, and thank you for joining us today. We're thrilled to have a couple seasoned pipeline veterans here today with us. Jerry Holton on my left, Mike John Jr. on my right. Jerry has 30 years of experience in the coating industry. He's been coming to our location for years, certifying our guys on the application of SPC coatings. So we thank Jerry for coming here today. Mike is our Vice President and Field Operations Manager. He's been in the business over 25 years, with the majority of that being in the oil and natural gas industry. So again, they're going to share their expertise with you today. We want this to be interactive, and we want you to participate. And in doing so, we have some swag here that we'd be glad to share with you based on your participation. Look at that bag of peanuts, folks. Isn't that great? And I'm going to turn this over to Jerry.
Good morning. I'm Jerry Holton with Unconventional Solutions. What we're going to discuss today is three things that I've seen out in the field on a fairly regular basis where people have holidays. I've coated a piece of pipe here just to kind of represent what I've seen out there and what Mike has seen out there. Mike quite often goes out in the field and is picking up and repairing somebody else's application. So what I've got here, just to start with, so we've got a spot here where a person used a wet film gauge and not doing what they're supposed to do, and that is overcoating it. This, if you run a holiday detector over it, you will have it'll Jeep at you. You'll get an indication. This area here normally would be the bottom of a pipe. We see this all the time where people go in and instead of looking at the bottom of the pipe, they just kind of reach underneath thinking they're getting it. Well, they leave a lot of bare steel down there. And then off to this side, we do not have any parent coating, but off to this side, something we run into quite often is the coating will be abraded back and the people will not cover the whole area with coating. So that again, when they run the holiday detector over it, they're going to end up with an indication there. What we're going to do is I'm going to show you how to prepare an area, how to apply coating. We're going to be using 50 milliliter repair cartridge. This is an SPC product. I'm going to show you two different ways of mixing. One is using the static mixer tip. The other, if you don't have the tip, you can mix it coming straight out of the tube. But people have a problem with that, and I'm going to show you what that problem is as we do it. So I'm going to put what they call the static mixer onto the tube here. It's really nice. These tubes are really handy, regardless of manufacturer. There's a lot of them out there. Because if you don't use the whole tube up, you can take the tip off. The tip will cure out and become a solid waste. You can stick this in your pocket and save it for the next one. So the tips are single use, the tube is multiple use. So I've got an area here. We're going to do the one with the one where somebody put a wet film gauge in, okay? When you're doing a holiday repair, you need to abrade the area around it. Most manufacturers stay to an abraded area a minimum of 1 inch around the holiday. So this is going to be a pretty good area. Now, also, a lot of the operators and the manufacturers state that you can only abrade up to a certain area before you have to abrasive blast. And that area can be 6-inch diameter. One operator is 4-inch diameter. So you need to make sure you're reading the operator specs along with the coating manufacturer specs. The most stringent would always apply. So we're going to sand this, and what we're doing is just creating, we're going to create an area around here. Something else that happens out in the field is we've run into inspectors over the years that tell you they don't want you to coat the whole area you've abraded. The reason for that is they say, well, then if you cover it all up, we don't know you sanded it. What happens then, and what I'm trying to do is get rid of all the gloss here. What happens is if you put your coating in the ground, your repair in the ground without covering that whole area, you're now putting the coating in out of manufacturer spec, because anytime you sand an area, you are opening up the matrix of the coating. That shiny surface that's on all the coatings is part of the moisture protection that goes into it. Okay, then you want to brush it off, make sure it's good and clean. Not quite an inch all the way around here. You get a little bit wider there. And it's good to use a non-metallic sandpaper. I mean, you use metallic, you can have pieces coming off, and you can actually have dissimilar metal corrosion going on if that piece isn't removed. So use a good non-metallic one. When applying the coating, some people will go directly on to this area, squeeze it directly on there. Some operators don't want you to do that. They always want you to go onto cardboard. Regardless of whether you're using the static mixer tip or doing it by hand, what is a good idea is to always squeeze some out first, just to make sure you got a nice even color coming out. At times you will see that it'll be a little bit more blue than normal, and that's just because of the viscosity difference. Okay, that's just because of the viscosity difference in the two parts, part A and part B. So I'm gonna put a little directly on here as part of this. Now I'm gonna apply with a brush today. Another way to smooth this out on there, I'm gonna do it in 2 shots here.
We got a question.
Yes.
Let me see if I can answer this.
Remembering that your minimum coating thicknesses for just about all coatings is 20 to 50 mils on your mainline pipe. So you need to have a minimum of 20 mils on here. And we're gonna brush this lightly because we don't wanna force that coating down into the divot we've created by sanding. We wanna have it a little bit above and nice and smooth. Okay, the other way of mixing would be to squeeze directly onto the cardboard. Squeeze out what you think you need. Now, what I run into, and a lot of people have seen out there, is they'll mix it up. I don't know if you can see that. You've got a dark blue and a white there. I've come up on areas where they've stopped mixing right at this point and put the coating on. Where you have bright blue or bright white, you're not going to have any curing going on. That'll stay soft forever. So if you have like a putty knife or something like that, you can apply. Trying to get this mixed good here. We don't want any streaks in it. We're going to go like this. Again, making sure that you cover the whole area that you've abraded, because if you don't, you're putting it in out of spec. If you run into an inspector, or if you are an inspector and somebody's told you to do that, please read the manufacturer's coating spec. It'll explain why we don't want that done. How's that look? I'm doing this kind of backwards. Okay, can you see that okay? I hope. Can they see it okay? Somebody say yes.
Okay, Jerry, we have a question.
Yes.
Why don't you want to push it down into the divot you created?
Okay, it's not a matter of not pushing it down into there. We're pushing it in, but when we come across the top, we don't want it going low, because then we're going to be lower than the manufacturer's requirement for the thickness of the coating. It'll kind of go, instead of being smooth across the top with the top of the pipe, it'll go like this. So we're getting it into the divot area, but then we're going to smooth over the top of it.
I have a question. What is the grit size of your grit?
Oh, I'm sorry. Most manufacturers require a 60 to 80 grit paper, because you can get something coarse. What we're doing again is just creating a profile the same as you would if you were abrasive blasting, but not quite as deep. That profile there is probably 2 to 2.5 mils if you were to measure it. Remembering that the gadget you use to measure profile on a steel pipe is not really designed to measure it on coating that's been abraded. Okay, so what we've got here now is an area that was on the bottom of the pipe. Or we're going to assume it was on the bottom of the pipe. Put that on for me. Again, we've got to sand that area. Something to remember, if you've got bare pipe showing, try not to sand the bare pipe, because if you sand it, you will take off any of the profile that you created while you were blasting. Sandpaper is not going to put profile on tape. on tape, on pipe. You also want to make sure you get into all the grooves that your brush may have left, because any place the coating is shiny, it's going to be kind of like paint and wax paper. The stuff's not going to stick.
All right, there's one question here.
Yes.
Would a Bristol blaster work for prepping the area around the holiday instead of sandpaper, or would this be too aggressive?
Okay, if you've got a holiday and you want to use a bristle blaster, where you're going to be at it, the thing you have to remember is you need that abraded area going back out, and it takes a real trick to hold the bristle blaster at the right pressure. So if you have a larger area that you need to abrade and clean up, maybe it's got some corrosion material in it that the sandpaper is not going to take out, that bristle blaster is going to create like a 3 to 3.5 mil profile. Use it in the main area of it, and then just sand around the edge of it to get your abraded area for your tie-in coat. Does that answer your question?
Yeah.
Yes, I wish I had a bristle blaster. They would work very good on a weld bead because they're going to get into the little nicks and crannies and clean it up and get rid of corrosion. If you've got an area where, say, you got a chunk of pipe and it's got a long streak on it, scratch on it, sandpaper is not going to take that corrosion out of that. That's an excellent place to use a bristle blaster. Go along it, clean it up, and then sand on either side of it. So again, we're going to, now this is, people, when you're doing welds, okay, this is a big issue. Most of the holidays end up on the weld, top of the cap weld. They end up where I showed you here, or they end up here. And again, if the coating is flowing into the little divots and stuff and crannies in there, and this is what we want to do. When you're coating this weld to begin with, the whole idea is don't stripe it first, coat it, but don't stripe it first.
Okay, we have
Yes.
2 questions. So first one is, do you recommend removing sanding dust, epoxy dust after sandpaper before repair application?
Yeah, we just did that. We took the brush, we brushed it off. That's all you need to do. No chemicals out there. Do not be wiping the pipe down with acetone or MEK or anything like that.
Great. And the second question is, what type of safety gloves are you wearing?
Blue ones. These are chemical resistant gloves. They're designed for use around epoxies and paints that would have your thinners and stuff in it. So just look at it, look for industrial grade. I saw some industrial food grade the other day, and I have no idea what industrial food is. But when somebody is coating a weld bead to begin with, if you look at this, you can see when I ran the brush over it, I created kind of a side going off. That is how it should look when you walk away from it when you're first coating it, so that Mike's crew doesn't have to come in and do this on the backside. If when you're coating your weld, you get that cap weld ripple totally buried, and you cover those button welds top and bottom, you're not going to have an issue. If you don't pay attention to that, you will. And the reason I said stripe it at the end instead of the beginning is you can brush the coating on this whole area. Do this at the end and walk away from it. Don't play with this stuff.
And with our experience, Jerry, is what we do is we will coat that weld first. What people call a stripe coat, but we actually coat that first to get even coverage all the way around that, so you don't end up with a holiday on the bottom of your weld.
Okay.
So that prevents that in the future.
And then you do a build up at the end.
Build up at the end and get
Okay.
your
So whatever order.
Yeah.
What we always ask for is the build up at the end though, because normally you've worked anything off of there and it's a thin coating on there. So off here now, if you can see this, we're going to pretend that this is all parent coating here, okay? This bare steel. What's happened here is the applicator got on there, and if you were to look at this, where the bare steel is there, that would be a braided parent coating. So you've taken parent coating, say an FBE that started out at 16 to 18 mils, you abrade it, you're now down to 9 or 10, you're jeeping at 20 volts per mil. Normally they're jeeping at what, 3,500 volts is what you're at? This is going to show up as a holiday because you've thinned the coating out too much. So in this case, if this is all coating underneath there, I got to rough this all up or bristle blast it. You use bristle blaster.
We do, or if, large diameter type, we even just sweep blast it.
Sweep it, yeah. So again, you're gonna sand that, get all the gloss off on both the parent coating and the application you put on there. And then my handy dandy sweeper is going to come in here. Yes, you always have to remove the powder. If you're coating the weld for the first time, you've abrasive blasted it, they've blown it all off, but you didn't get to it right away. You want to make sure just before you coat, you always take your brush and you brush all the dust off. You don't have to wipe it off with a rag. I've caught people out there wiping a weld off with a rag with acetone on it, and rag pulls loose, and now you got little pieces of fiber in there, and you're asking for an instant holiday or Jeep indication.
All right, we have another question.
Yes.
Is this a different coating than what was first applied? If yes, why would you use this over what was first applied?
This is the same manufacturer, okay? It is the same product. The reason there's a color difference is because we're dealing with small little tubes, and the color is just a pigment. It has nothing to do with the curing of the material or anything. And mixing it for small tubes, sometimes you'll have a darker blue going on than normal. But this is the light blue is SPC 2888 RG brush grade. This is SPC 2888 RG brush grade, just because the pigment difference in there. Questions? Come on. So this area out here that we're coating, we haven't really got a holiday. We've just got thin coating there, and we need to seal the surface. So you're not having to deal with covering bare steel up with 20 mils. What you're dealing with is sealing the surface of the coating. So you can put a little bit thinner coat on there. Because you remember, the 20 mils is out here, right next to the weld bead where you've got bare steel. Starting about here, you would have parent coating. So you're not looking at 20 mils of 2888 on top of that. You're looking at sealing that so that you don't have any failure of the coating, premature coating failure due to moisture getting through it. Yes, Doug?
On the weld, do we want to look for those little pinholes that you can't see from where you're at?
Oh, back here?
Yeah.
Well, you're going to look for it. That should be something that normally wouldn't show up.
Okay.
You're putting the coating on to begin with, your first coat before we even get to this spot. That's where you're going to look for the pinholes. Here, the coating was being pre-mixed coming out of the tube. The only time you're going to see pinholes is you start force curing it by adding some heat to it. And you can preheat the pipe, or you can heat the coating afterwards. The whole trick with preheating afterwards is you need to make sure you hold that heat gun, and you do not use fire. We don't use those little butane burners. People tend to like coating on fire with those. You use an electric heat gun. A Wagner paint stripper gun that has a 1,000-degree setting on it is ideal. Milwaukee makes a good one. You hold it at a distance, it will heat the coating, but won't blow on it. You have to remember there's a fan there, and if I blow on it, it's going to cause the coating to ripple back. Does that answer your question?
Yes, thank you.
Okay, we got another one. What are the temperature limitations on the repair kits when applying? Would a preheat be required below 40 degrees?
Okay, coating has to go on minimum 50 degrees Fahrenheit, 5 degrees above the dew point. Top end for 2888 for application is 212 degrees. So you can preheat anywhere in that range, remembering that the hotter the pipe is, the faster it cures. So, I mean, you can put it on, if I'm repairing and I want it to cure in a hurry, I may put it on at maybe 160, 170 degrees, and it'll cure fairly fast if I add heat after the fact. Again, being careful not to get the gun too close, because that's going to cause bubbles, and then you're going to be back in there repairing it again. And we've gone in and repaired repairs, and that's what we're talking about here.
Okay.
Does that answer your question?
I believe so. Continue.
Well, we're just about there.
How long does a repair take to cure?
It depends. Epoxies generate their own heat. So the hotter the pipe is, or the hotter the epoxy is, the faster it cures. With these, I keep them in my pocket when I'm not using them. With these, I'm showing it to that camera. I keep the cartridges in my pocket when I'm not using it. It keeps it warm, and then I'll add heat to the pipe afterwards. So I don't have the cure chart in my head, but if you were to apply it at 50 degrees Fahrenheit, that's the long end. It's going to take you about 14 hours to cure. I believe up in the 180s, you can cure it in about 3 minutes.
Okay, we have another question. Do you recommend repairing two-part liquid epoxy that was applied and cured below final DFT below specification, i.e. Less than 20 mils, or would you require removal and recoat?
That would depend on the area you're dealing with. If the inspector got in there and found an area, and I'm going to use the SPC specification, found an area that was less than what 12 inches diameter, you can hand abrade that area. If you're higher than that area, then you would have to abrasive blast. There are operators out there though that are 4 square inches. That's a 2x2 area. There's one out there. Some of them are going with 6 inches. I believe up in Canada, the MQAP that Enbridge uses, I think is 6 inches. So,
Good.
Does that answer your question? Drop my watch again. So, I mean, that's pretty much it. It's not the prettiest thing in the world, and you can keep smoothing it out. The thing you want to watch out for is if you've got a holiday on the bottom of the pipe where this might be, you have to treat it the same as you would actually applying. You want to go uphill on it, because if I went downhill on it and took my brush off at the bottom, I'm going to pull icicles. So with any of these liquid epoxies, you can put it on any old way you want to begin with, but you always finish going uphill to take your brush off uphill so that you don't help gravity and create icicles. If you run into icicles, that's another place you have to deal with. You know, they have to be taken off before the pipe is put in the ground. You have now opened up the matrix of the coating again. You have to sand them and treat them like a holiday and coat them. So it's just more work. So the thing is, do it right the first time. But if you do have to repair, take a little more time to do it so you get everything so they're not back in there having to repair it again and again. And I've seen that, especially when they hand mix these. A pipeline about 10 years ago, about 30 all the way down the line, where you could take your brush handle and you could push it into the coating. It was so soft because it would never cure.
Another question is, what size brush?
Okay, this is a 2-inch brush, which works really good for holidays because you don't have such a wide area to deal with. Normally when I'm coating, I will use a 4-inch brush. And again, if you want, I'm not going to use the steel one. I get plastic putty knives, like little 3-inch plastic putty knife or something like that, and I will smooth the coating on with that sometimes.
Excellent.
That's all I've got. Please send your questions.
You got anything else?
I think it's great. The comment is, you know, the way we were trained a long time ago and what we see in the field a lot is a lot of people will bring that brush down in the bottom of the pipe, and when they pull off, they expose that steel again.
Yep.
So as you said, go from the bottom up on all your strokes when you're done, just level that out and alleviate those icicles and those pull-offs where you do pull off that coating off that cap.
And that's when you have to go back in and repair your repair.
Correct.
Because people don't normally check where they've repaired right after the fact. They wait for it to cure, then they run the Jeep again, and oops, we got bare steel again.
Creating more work.
Creating more work for you. So
Thank you for your time today. We thank Jerry and Mike. A special thanks out to Jolie with Vesta Construction website. She's the one to help put this all together. And so we hope you learned something today. We'll follow up next week with you with an email. We'll be doing some drawings for some swag, and we'll announce those people in that email as well. And have a great Friday.
thank you very much.